Okay. All right. Here's the disclaimer. So this meeting is being recorded, and by continuing to be in this meeting, you are consenting to be recorded. So good evening, everyone. I hope everyone's doing well and keeping up with the course, and really are enjoying this course so far. So this is our Module 2 webinar, and this we will have other 2 webinars after this for Modules 3 and 4. We'll meet every alternate Thursday. So after this, we'll be meeting next 2 weeks from now. Okay. So as soon as my screen starts working here, some meeting etiquettes, but seeing that not too many here in this session today, and we had a nice little small group here, which is good. I can let you be on your video. Only thing is if you have things going around, wherever you are, please mute your microphone to limit any distractions around you. For questions or comments, as I said, this is a small, there's a small group here, so please feel free to stop me, questions. And if it takes a long time, I'll ask you to kind of wait till the end, and we take it up later, just to make sure that I can still time bound this particular session for an hour and a half. You can also put it in the chat room, but once again, just say it out here so that I don't have to kind of keep watching the chat room, or Yelena doesn't have to keep watching the chat room. Webinars will be typically an hour or less, and the maximum time, I won't keep it for 1.5 hours. I'll keep it for 1 hour, 15 minutes max, any day, anytime. Okay, all right. And just, once again, I'll try to send the Zoom meeting invites out during the week of our webinars. So typically on a Monday or a Tuesday, you will get it for a webinar invite. Get a webinar invite for a session on Thursdays. Okay. With that, I know this being the first session, I'm not sure if you got introduced to Yelena. Yelena is going to be the TA for the class. Some of you may have already worked with her, and Yelena has been an excellent TA for us for many, many years, even prior to me joining UMGC. So, and she's been pretty thorough and very much knowledgeable about all the content within this class, as well as the assignments. So please take her help anytime you need. Please do not wait if an issue occurs. And as soon as you kind of send the time. So one of the reasons why I asked you to go over the course introduction webinar was to ensure that you get introduced to not just me and Yelena, but also to how you would put in a ticket for any issue that you may have. So there's a Salesforce ticket system. Some of you may have used it in the past. If not, there's a link that is being provided, and you got some instructions in the course introduction webinar on how you would create that ticket so that it flows through to Yelena right away. In addition, you can always email it to me, and I will copy Yelena for any issues that may occur. Okay. So with that, with all that housekeeping, let's move on to the agenda for today. We'll go over the big data management. We'll then go talk about the assignment 2, and then take in any questions you may have towards the end, and I can take it in between the session as well. Okay. So on a quick retrospective on weeks 2 and 3 so far. You submitted quality and timely deliverable towards your assignment 1. Awesome, guys. I mean, I just came in at the time when I had to grade your discussions, and your first module 1 discussion and your assignment 1. And you guys started off so well. You've already raised the bar so high, and I want you to kind of keep up to that, keep the momentum going. Okay. And you'll tell me that this class was a breeze and you'll be all successful. And that's my goal. But once again, we have to maintain that gold standard and to ensure that you're doing well in your discussions, in your assignment. But to me, I liked what I saw so far in this class. Some of you have not accessed and logged into the AWS Academy Lab. So please do so. This invite was sent to each of you. So if anyone here or watching this webinar later on as a recording, please make sure that you have the access or you've logged into AWS Academy Lab after you've received the invite. If you have not received the email invite, please let me know right away. Without the access to to this Academy Lab, you will not be able to complete all your future assignments, including assignment 2. So all your assignments from this point on is going to be in AWS Academy Lab. Okay, so very, very important step. Okay, so and I'm keeping an eye on who's not. So I did resend an invitation again for a few of you who had not logged in earlier this week, and I'll check in again tonight. But you have one more chance to kind of do that. And as always, please take advantage of these webinars, these touch points, the in-person touch points that we have to make sure that, and I know it's not complete and truly in person, but I think we can make it really a live session, and we can take advantage of this live session by bringing in your questions that you may have or anything that could be on your mind, right? So please take advantage of it and try to be here. We'll have, as I said, 2 more webinars after this. All right, as far as the discussions, I think I kind of did set it out in the announcements. As you may have seen, I love to send reminders, announcements, and you may have already sent and seen that that last couple of weeks that I've been part of this class. I ensure that I kind of send you more information and announcements. So please keep an eye on that, and also especially for discussions. As discussions, I want to kind of make sure everybody is aware and know that there's no late submission for discussions. Unfortunately, it is, no matter what, it has to be closed on the day that it's due, and there's not going to be any kind of an extension, right? So that's one thing. Make your initial discussion as soon as possible. So let's say you start your week on Tuesday. Try to make your posting by Saturday or latest by Sunday, because as you know, the discussion is meant for your enhanced learning by engaging with your classmates, by engaging with me, by sharing your thoughts, understanding others' thoughts. So it's not just about putting something out there and just commenting on others. It's about learning, and it's an enhanced learning for you as well. It's a supplemental learning. So please take advantage of that and post it as soon as possible. Comment on at least 2 of your classmates' postings. Very important. It's not just you reply to whoever asks you on your posting or any questions on your posting. It is about commenting on 2 others' posting as well. Post your reply to your classmates who have responded to your post, right? If they've asked you questions, if they've commented, just simple etiquettes, right? Thank them for their comments or answer and respond to their query if they have. And if sometimes nobody happens to respond to your message, especially if you have chosen to submit it on your initial post close to the end of the week, then if that happens and the class week is almost over, then respond to your own posting with additional comments, right? You can enhance your own posting or comment on your own posting about, some enhanced material. And this is still, once again, not a substitute to comment on your classmates' posting. So you have to do that, right? 2 of the classmates. Besides that, if nobody's responded to your own posting, you have to enhance it, right? With responding to your posting. So very important. Okay. Any questions here on discussions or anything that we have covered thus far? Is everybody with me?
Yep. No, I don't have any questions.
Okay, thank you.
Yep, no questions. Thank you.
Sounds good.
Excellent. All
No
right.
questions.
Okay.
No question. So far, so good.
Thank you, Avner. Okay, so now that know that you've gone through a lot of material. I know there was a lot of reading this week, and I could see that from your discussions. As I said, it was wonderful chatter, loved the discussions, loved your engagement in the classroom. So now with all that, right, let's put it to test. And I shouldn't use the word test, but let's validate some of the statements that I'm going to put it up on this slide and see what are going to be your comments, what are going to be your thoughts on each of these statements, okay? So let's say if the statement is just increase the size of your database to include more data. That is how easily you can manage big data. How would you react to this statement? What is going to be your comment? Anyone? Please volunteer to speak up.
I would say the statement's kind of false. I mean, obviously, it's also about how the velocity of the information's coming in too, which is why we use Hadoop and other things like MapReduce inside.
Yeah, okay. Anyone else? Does everyone agree with Sheldon just mentioned, or any other thoughts on this statement? Yeah, right. So yeah, just be increasing the size of the database. I wish it was like that. Then all our RDBMSs, we would have just keep enhancing, adding disks to it, and still managed larger data. But that's not always the case. And so just by increasing, you may be able to manage additional data. But whether you can manage big data, well, it's a big question mark there, right? So that's definitely right. The next statement here, RDBMS cannot handle or manage big data. You need other emerging database types. What do you guys think? I don't want to put anyone on the spot, so please do not hesitate to just respond to it. And there's no right or wrong answer, so please do not worry about that.
I
I
think
would
it's
say
definitely.
it's true. I'm sorry, go ahead.
Oh, no, you go ahead first.
I was just gonna say, I think it's true only because depending what type of data you're gonna hold, whether it's like social media data such as videos, pictures, etc. To my knowledge, I don't think a standard relation database can handle that.
Okay. Anyone
And then what I was
disagree,
gonna say,
agree, or any of the comments? Yes, someone was saying, sorry.
Yes.
yeah, no, like one of the things I was reading about for the discussion board for this week, when it came to really both comparing and contrasting data lakes versus data warehouses, that you don't have to think of them as sort of binary different approaches. You can use them complementary, excuse
Yeah.
me, as sort of taking the the semi-structured, unstructured raw data approach of data lakes and then organize them into data warehouse. There has even been fusion approaches called data lake houses that have come up that have been able to take the sort of raw data approach of a data lake and then run it through the sort of metadata management system of a data warehouse and then still be able to organize it ultimately still like a data warehouse when the data is eventually stored.
Yeah, true. So with RDBMS too, I mean, don't get me wrong, but depending on whether, and we'll be talking about that soon, but if you are really looking for asset type properties, right, for the type of data, if you're like working for a financial institution and you are really looking for an asset properties for your database, maybe you'll have to stick to RDBMS, right? And these days the RDBMSs are pretty robust, right? They've really been around for decades now. Like some databases like Oracle have been there for decades, and it has come a long way ever since it started to. And we'll talk about the evolution of databases soon, and also about asset properties. But yeah, they've come a long way to manage a lot of different types of data, like even like images and audio files and objects, right? All those different objects that you would call. they can probably even, handle that kind. Now, whether, the velocity kind of data or high velocity kind of data, or really, unstructured data, and how would you structure them? And if it is not structured, how would you still retain? That's the kind of questions you aren't. But yeah, I mean, RDBMS, I would say this would be, cannot handle or manage big data. Well, it's kind of a yes and no, depending on what the application is, what your needs are. Make sense, guys?
Yes.
So, okay, here comes the favorite topic. Data lakes
Yes.
or data warehouse are the two sides of the same coin. Same thing, but different names.
I disagree, obviously.
After all that chatter and all that discussion, just a few minutes back, even here, yes, you'd all disagree. It's not the two sides of the same coin, although they could be used in tandem, right? They could be used in tandem, or they have their own advantages or features. So, yeah, absolutely. Okay, so this was an easier one. All right. So with that, let's talk a little bit about the databases, the evolution of databases. And I know this is not very legible, so don't worry. In just a few seconds, I'm going to zoom in to the different parts of these of this infographic, which I really loved it. And by the way, I've shared the sources. I typically, if I share some pictures or things of that nature, which I have picked it up, I will definitely share the sources with you. So do not worry about it. It's there on the slide. So, and then I kind of like the infographic because it kind of put in the entire evolution here in a single infographic. So I loved it from that perspective. So when did it all start? Like the database itself, the concept of database really goes back to 1960s, really. So if you think about it, that's almost 60 years back now, right? So yeah, I mean, to think about it, that, they have been, of course, if you can think, it's not too long, but at the same time, they have not been, it's not just happened yesterday, or you've started to see them just a few years back. They have been around for so long. And no wonder some of these databases have evolved and become so robust. But anyway, it started off with having the network or hierarchical type databases. Relational database was not the thing that time in 60s. And also these databases were not commercially available. They were used mostly for research in universities and on this research agencies or government agencies. That's where these databases were meant for, really, not for commercial usage or purposes. It was in 1970s that things started to evolve more. There was a nice paper by Codd, who wrote a paper on relational database model. And based on that model, there were systems, a couple of database systems that were developed, right? The single instance relational databases were developed, and systems like, or databases, DBMSs like System R, which was developed by IBM, which came along with the first time with the SQL, with the structured query language in 1970s. Same thing with Ingress, which is a predecessor of Postgres, came along with its own query language called Quell. Once again, similar to structured query language. But this was the emergence of the relational database systems, right? But not, once again, not commercially still in 1970s. But this was the, I think this was one of the decade where you saw that there was a faster development on when the databases, before it became commercially available. There was this entity relational database that gave like a graphical, that would provide a graphical view of the database, where it became easy to lay out the structure of the database, see the structure of the database, design your database, right? Then right after, when this thing, when this design of the databases got evolved, you saw the very emergence of the very first commercially available database, the Oracle, which kind of came into play in 1980s. And this was the time that, Oracle, and then came DB2, then came, Sybase and Informix. And these databases are around and have been around for a very long time, or they've been around for a long time, and some of them may appear to be extinct, but they've been very robust systems. And as you can see, just if you think about from 1980s, today's 2023, and many of them are still around, especially Oracle, right? So that's been like 4 decades, and that's of being around. But yeah, at that time, you saw also that the object oriented languages also kind of coming into play, right? C++, Java, and then came along the object oriented databases, because you saw the emergence of social media as well. Not completely, but yeah, the people had started to see and work with images, with audio, and all that, and geographical, information, kind of a data. So all that media content and geographical information content, all that kind of came into play, really creating objects. And how would you save and store all these in the database? That's where the emergence of object-oriented databases. So fast forward to 1990s, that's where you started to see the shift, right? You started to see the shift that, because of the decade of companies storing their data sizes increase it, right? and the companies becoming more reliant on the databases. The companies that were so big, or so, they were so widely, or scattered around, geographically, that the emergence of distributed databases, right? They were placed in multiple zones and regions and locations worldwide, right? So that came, the emergence of internet came into play, and internet brought in all these, not just the challenges, but the opportunities of this database to grow beyond a single instance to multiple instant databases, right? So that's, and also the data warehouse. Now you got lots of data. You saved the data for 10 years, right? And now you want to really make use of it, gain some valuable insights, and act on it. The business intelligence, right? So for that, you needed like something like a warehouse. So that's where the warehouse came into play, because yes, as I said, 10 years have passed by, 1990s. All the companies are using databases, or most of the companies, and they need something like a warehouse, right? So that's when it all started. Now, 90s was the time when, yes, there was all these distributed systems, multi instances of databases coming into play. Then 2000 saw like a huge, and it kind of started to spread out as we started to use more and more of social media, and different types of data coming into play, and the speed of data coming into play, the big data, the emergence of big data. It led to the evaluation now kind of spreading out to to NoSQL type databases, to distributed SQL databases, to even the warehouse going through a lot in how they were being the architecture. Hadoop is kind of emerging. So all this is kind of emerging in the early 2000s, right? And that's how we are seeing that all these different data types. Now, there's like, depending on your need, of course, you would go to one database or the other. There was not like a huge competition that, oh, there's one knocking out the other. As you can see here, they were just kind of keep flowing in. Yes, we went from single instance databases to multiple instance databases, to being, in massively parallel, processing and all that. So computing, power increased, and you started to use multiple instances of databases. You started to use Hadoop, and based on, of course, as I said, based on your use case, you would go to one type of database to another. But that's when it all started, and it's where we are today, with all these database systems into play. So just a lovely infographic, just telling you this nice story of how databases evolved, and how few databases, and they were like coming from just a couple of different types to seeing multiple different types of databases. And this has grown so huge. If you would have to Google today the number of databases that you can select, it's immense. There's hundreds and thousands. Every day there could be a new database coming up. So how do you really select, right? Even there's databases on the cloud, databases on-prem, databases that you can use on your laptop, databases that you can use on distributed system. There's MySQL, there's Oracle, there's Amazon Redshift, there's Microsoft Access, and there's Elastic, there's Cassandra, and the list, and this can go on and on and on. So how would you select a database? It's a big question, right? Today, yes, choice is sometimes directly proportional to confusion. More choices, more confusion sometimes, right? How would you just break things down, and how would you go on to select the database? Now, let's go through some of the criteria on selecting a database, right? First and foremost, what's the simplest criteria or the main important criteria? What is your budget? Do you have the budget to buy a Mercedes, a Tesla, or a BMW, or you have just a two-door car that you could just drive around, right? What's your budget? So the budget of the database, by the way, I'm not talking about the budget for your car, but yes, exactly. Based on your budget, you will go and buy something. So first and foremost, you have to know how much can you spend, really? Well, as a corporation, how much can you spend? As an individual, how much can you spend? And that's going to really, you'll start filtering out based on the different criteria that we go, you're filtering out databases. Some of those databases, a BMW is out of my reach. I'm not thinking of BMW. Take it away, right? Heavy duty databases, I don't need. I just have this budget here for a simple single instance database, right? So once again, budget, the important criteria. What type of data will reside in your database, right? So once again, is it a simple structured data? Are we talking about unstructured data? Or is it a social media type data? Or there's a media content, or so whatever, depending on the type of data that's going to reside, again, can dictate what type of database you would go for. What is going to be your user base, right? Do you have a set number of users, a very low user base, or is it going to be a wide organization and a wide user base that you would have, or a large user base that you would have, right? That is another dictating factor. How frequently do you need to update the database, update the database schema, and refresh the data, right? So if once you start to put in the data in there, and now if you have to update the database schema, is that something that you plan to do it frequently, or you plan to do it refreshing the data? And is your database going to be able to support that, right? Is their database able to have a really low downtime in order to ensure that you can do these tasks here, right? Will you need to access your database 24/7? Is that your criteria? Is that you cannot really have a database that's going to have a really long downtime for maintenance purposes, right? You need your databases up most of the time, so 24/7. Do you need your database to be highly scalable? You're probably starting small, but you think, well, my business can grow. It has got great potential. Today, I'm with this many clients. Tomorrow, I'm going to grow here, right? Or my data is going to keep growing. It's never going to shrink, or it's not going to stay stagnant or similar size, right? The size can grow or multiply. So is that a criteria to kind of keep in mind? Is my database scalable in a way that I just add disks to it and additional disks to it, and everything will be okay, and I'll be able to increase the size, right? Is that database will be able to do that or handle that, right? What kind of throughput and latency do you need from your database, right? Throughput is like the number of transactions per minute, right? How many transactions really do you need? Like really the performance is important for you, that all the transactions that are going to fly by, they need to just, that's important for you. And the latency, right? How much time does it take for your transaction to complete? Is that performance also a key criteria for you, right? Faster the better, faster the better. Yes, we all want faster the better, right? We all want to fly through. 0 to 60 in 3 seconds. Yeah, everybody wants to do that, but is that what you really need, right? So same thing here. Same thing for the database, right? Do you need, what kind of a throughput do you need, right? And that's going to be another criteria, and or something that will weed out different databases. What systems and tools do your database need to integrate with? Very important, right? And this could be a very important consideration, especially for corporations that have been around or individuals that have, even in for your smaller systems, if your database has to integrate or work with certain other types of databases and systems, and also it applies to even resources, right? You could buy one of the best databases, but you don't have anyone in your company and your organization to manage it, or your organizations have other databases that database is not going to be compatible or work with or integrate with. What's the use of that database, right? So very important criteria, which you will have to really answer this. Yes, I can buy. Yes, it checks all the boxes, but one important box, I don't have anybody to manage it. I'll have to either hire someone, or my people have to be trained, or I cannot get this database. And importantly, I have got other systems that it needs to work with. I've got a DB2, I've got an Oracle, I've got this. It better be compatible with that, right? Integration is important. Is your database going to be on premise, or is it going to be like, is it shared by different departments? Is your own department going to have your own, it's within the same location as you are in? Important criteria. Does your database need to be located and accessed worldwide, right? Is your company, is your organization spread out in multiple locations worldwide? Does the database need to also be available worldwide? Are you planning your database to be on the cloud, right? Maybe if you want to, like if you're cool, if it is worldwide, maybe you can think about cloud. If so, that's something that you are okay to do with, right? And lastly, and my most popular statement here, are you boiling the ocean, right? Can your data simply reside in the files on your computer? If you have few thousand records that you want to keep and maintain, or few hundred records, do you really need a database, right? Do you need to invest in a database? Can you just simply use Excel? Can you simply use a text file? Maybe, right? So if you can do with a simple two-wheeler or a simple two-door car, you don't need to buy a Mercedes. You don't need to buy a Tesla. You don't need to buy other fancy cars. A simple two-wheeler can do the task for you, right? Same applies here. So different criteria to, even before you kind of think through and take this little more and think about the more technical terms, these are the things that you will have. These are some of the different criteria that you can think through, and this is going to then weed out some of the databases. As you keep answering these questions, you'll see some of the databases that are kind of now it's off your list, right? Next important aspect to think about from a technical standpoint, ACID properties, right? And ACID is an acronym for atomic, consistency, isolation, and durability. And you probably read through it, so I'm not going to spend too much time, but atomic, right? Atomic meaning, an example, if you have, if you're doing any transactions, if you're transferring some amount from one account to the other, the debit from one account to credit to another account should both happen, right? It is one single transaction that needs to be completed, right? And atomic. So if it cannot be halfway through, right? Otherwise, you're going to mess up this whole transfer. So the full transaction either completes or it doesn't complete. It's completely atomic, right? This one full transaction. Consistency, right? If your customer is changed in one place of your system, the other parts of the system should have those changes, right? Or if you have removed a customer from one part of your system, the other parts of the system should not see that customer. Same thing like in a university, right? If you got a student ID, it should be a unique student ID across the entire university system. Think if there's two people with the same ID, what could happen, right? And also if there's any changes to this ID, this should be consistently across the different departments of the university. It should be changed. If your address is changed, it should be changed all over. If you got certain scores in certain in exams or in a certain semesters, it should be all there in one place. Everything, anybody who accesses your records should get the same snapshot of your record, right, in the university. That consistency is important. Isolation, like let all transactions run independent of each other and be completed. If your transactions that are being, dependent on each other, or there's a race condition, A completes if B completes and B completes if A completes. If you have that kind of a condition, that's a kind of a deadlock condition. And your transactions are not isolated. They're being dependent on each other, right? You don't want that to happen, right? You want that to be isolated. You want durability, right? Like in case your system crashes, it should save the last snapshot of your data, right? So when your system comes up, it should be back to where you left and not anywhere else, right? So that's important. So are asset properties important for you, right? You have to think about that as well. Then maybe if you are moving from, transactional integrity or consistency and moving to, let's say, towards being highly scalable or available kind of, or highly scalable kind of systems or distributed kind of systems, then maybe you want to think about base, right? Basically available, soft state, eventually consistent. For example, let's take a social media application, right? How would you apply to this, right? Let's take that application and look at these three things here. Basically available means so let's say if you have a social media application, if some parts of the application is down, even then you would want your application, your basic functionalities to still work, even though not all functionalities are working, right? Like if you have like a Facebook kind of application or something else, if some parts of that social media application or Instagram or whatever you're using, you still want that application to keep running, right? Okay, one piece is not working, fine, but the main other pieces are working, or the basic functionalities are working, so let it be working there. It's basically available, right? Soft state, right? If let's say if you are okay, like if you change your user profile, well, for a few, it could be now, I'm just thinking of like, it could be few microseconds to few seconds to few minutes. You could have your user profile, the old version and the new version, floating around in the system. And it may eventually change, but yeah, of course, there are two different versions, and maybe it's okay, right? At some point in time, you'll get the same exact version, but let's say you made a change, and maybe someone else who's accessing your records may not see that change right away, right? So that could be, you're okay with that soft state of your data. And then you're okay with eventual consistency. So eventually the data will catch up. The messages that you post, the profile that you updated will be seen by everyone, right? It will be published everywhere. And all the nodes of that particular application or wherever it resides are having the same exact copy of the data. But this is when you're okay with that. You don't need asset properties for social media type application, right? You're probably okay with base. And then for highly distributed systems, you could probably think about think about the cap, right? When you are having highly distributed systems, as far as you could get only 2 out of the 3 properties at the same time. You can either have consistency and availability. Available means the data is usually available as and when you request for it. And consistency, we just talked about the consistency of data. So you could have either consistency and availability together, or partial tolerance, partition tolerance and availability. Partition tolerance means that even if your data, if the network that, it gets, probably multiple, clusters, right? If your clusters are multiplied, right? Instead of being in a, it did partitions, your clusters, partitions, and it's in multiple clusters, you're still going to be okay with that, right? And your data is still going to survive. Your application is still going to survive, right? In that case. So you have, you can have availability and partition tolerance. You can have consistency and partition tolerance, right? And there are some examples here, like, for each of these kind of combinations, but you can have only 2 out of these 3 properties, right? So when you have a highly distributed system, so you should be, knowing this and also be okay with this aspect. Okay. Any questions on the different criteria that we just talked about? Does this make sense?
No questions for me.
Okay, right. Thanks, Steve. All right. So moving along, so just putting up this snapshot from one of the surveys that were conducted. And by the way, when you go to multiple, you search for different surveys and you see the top 10 databases put up by different surveys, it may not be too different, right? I mean, they're all pretty much, most of these databases would be part of that other surveys as well. So, not too different from, but this was one of the surveys that I thought I would just put it up here to show, what are some of your top 10 databases that we had seen in 2022. Oracle tops the list, MySQL, SQL Server, PostgreSQL, MongoDB, Redis, IBM DB2, Elasticsearch, Microsoft Access, SQLite. These were some of the top databases that are some of the most popular databases last year. And then there was another survey which was done in Stack Overflow. It was a developer survey, and these were, especially they were looking for which were best or the most popular databases for web applications. And once again, some of the databases from the previous slide also appear here as well. For example, MySQL or PostgreSQL or MongoDB and Oracle, and they still appear in this one as well. So many of the popular databases, they could be applied for many different purposes. That's going to it shows that, right? So just giving you a snapshot of what are some of those popular databases that you can think about, right? And of course, going through the different criteria for what you would need, right? And based on that, you can think about the database for your corporation or for organization. So there are some, now that you may be also working in AWS, I thought I would just put up this list as well, that AWS has got, AWS Cloud has got multiple databases. There are the relational databases like Amazon RDS, data lakes like AWS S3, our lake formation. By the way, we'll be working with AWS S3, the data lake, in this particular assignment. There's a data warehouse. There's NoSQL databases like DynamoDB. There's a graph database. There's a document database. As you know, there are 4 different types of NoSQL databases, and all these 4 types are available within Amazon AWS. So there's document database, there's a columnar database, there's also in-memory database, which has got some excellent latency, right? Especially for gaming type applications. You need databases that would have like a micro latency. And this type of databases like Elasticcache, MemoryDB provide that kind of a micro latency. Okay. So anyway, so I'll provide a link there to kind of, if you want to just go through the databases that AWS provides. Okay. So to end this topic, just some food for thought. And also, while you're going through this module, is how would you take your learning about big data management forward? Start thinking about, right? You've just scratched the surface, right? There's much more, and how you're going to take this forward. What is your plan to practice the knowledge and skills you've learned during this week? And have you researched your areas to find big data sets and databases for practicing your skills. Start thinking about it, right? As you go on to learn about different aspects of big data and advanced data science, please keep thinking on it. And I'll keep bringing this up, guys, right? Because as I said, this is in 8 weeks of this course, you're going to just scratch the surface. And I want you to take this, use this opportunity to know about how to kind of get started and do more learning on it, because yes, you want to kind of keep honing your skills, keep learning more, keep practicing more, right? You have got a full AWS lab, and there could be ways for many of the things that you learn here, you can go and implement it. The AWS lab that we are going to talk about, this assignment, may take few minutes, right? Or just maybe less than a couple of hours. And it's, do not stop there. Try to do it multiple times. Use it. You got a full $100 credit. And the most people who kind of have used the data as AWS multiple times, like yours truly as well in the lab as a student, we have not crossed $35 to $40, right? So it's like you can really do as much as you'd like. Of course, if you remember some of the best practices when you're working on it, and we'll talk about that as well. But so once again, start thinking about how you're going to take this forward. All right, so with that, we'll move on to assignment 2, like a quick time check. We are okay, 8:18, so 12 minutes. So I think I would not take a lot of time on this, but I want to still quickly run through what assignment 2 is. As some of you may have already seen, and I know a couple of your classmates actually just went through this full exercise and they submitted it. So at this assignment and submitted it. So it has got all the instructions, and it will appear to be a very long document, but trust me, the idea is to give you and show you a snapshot of each and every step in the lab. So it takes away all surprises or any surprises that you can have. But having said that, I want you to start early so that if there's, for any reason you stumble, any reason the AWS is not working, the cloud is down, or the servers are down, whatever, you can still circumvent that and complete it on time. And this assignment has one aspect here that I want to emphasize and ensure that you remember, is that there's a quiz to it. Your assignment 2 is not complete unless you complete the quiz. And I'm going to give it away here. This quiz is not a memory test at all. It's not going to ask you, hey, when you click this, what happens in AWS? Sorry, I'm not going to ask you those type of questions. I'm going to ask you about what you captured, right? So if you've gone through each of the steps, if you have answered the questions within the assignment, like all those different questions that are asked, and the screenshots, if you have taken it, that's exactly I'll be asking in the quiz. There's nothing more. So do not wait a long time to take the quiz thinking I have to kind of memorize this, or I have to go over this assignment, I have to look at these screens, remember the screens. No, if you have gone through all the questions in the assignment, done. If you have captured them in your document as the way it should be, you are set for the quiz, right? Okay. So the purpose of this assignment is to prepare you to load data into AWS S3, the data lake, to use it as one of the most popular big data storage solutions such as data lake, and then make use of other AWS services such as Glue and Athena to apply structure to the data loaded in the data lake and explore and analyze it using Athena. So what you're doing is, and I'll show you via picture as well, that you're bringing in the data into AWS, into the data lake, and then you're trying to apply structure to it and then process that data and get some insights from the data, okay, by exploring it and analyzing it. So in this scenario, the goal is to use the data. There are 3 files given to you. One is the loan applications file. The other is the applicants credit bureau pools. There are like credit bureau information, and there's some credit bureaus transactions that have also been provided. So there's 350,000 1,000 or so applications. There are 1.7 million bureau credits, and there's almost 27 million bureau balance updates that have been provided by Home Credit to explore and analyze further by primarily using data lake to save the data and then use Athena to analyze and enrich the data set. So currently the Home Credit, so decision that we have to make here is you'll be, as when you get to the end of this assignment, you'll be able to make a decision on what the to whom the Home Credit can provide loans. And they can only provide it to certain small group of people, right? 50 to 100 applicants. And these people who have a long credit history and they do not have a credit or a past due credit by more than 30 days for more than $10,000. These are the people that you're going to choose, right? And you are going to kind of go through that assignment. So simply put, visually, you're given 3 CSV files or Excel files, and then these files, you are going to load it into the data lake, into the S3. You then let it go through a glue crawler that is going to apply structure to this data that it is bringing in, right? You're just bringing the data as is, right? You don't have any data, any tables or anything of that sort. The crawler is going to look at the data and it's going to know, okay, this is the structure of the data. And this is, so it builds the structure for the data that you've just pulled into S3. And then once it gives the structure, it then saves it in glue, right? It saves it in glue. And once you've done that in glue, and it can be then pulled into Athena, and using Athena service, you can then have a quick full analyze it and have a visual of your data as well. Okay, so you can run queries and it will show you all that. Okay, so that's what this assignment is. It's a very interesting assignment, still, and yet a very simple assignment that you have to go through. Okay, but the prerequisite here is that you completed establishing your student account in AWS Academy. It's mandatory that you have you have to make use of this lab to complete it. Remember, you cannot just say, okay, its lab is not working for me, I'm having problems, I'll go somewhere, I'll have my own account, I'll put a credit card here, I'll do it. Please do not do that. Your assignment has to be done through the lab. And if it is something is not working for you, you have Yelena and myself here to help you through this process. But it's not difficult. As I said, 2 of your classmates have gone through it and very quickly are able to finish this whole assignment very quickly, okay? So just so you know that it's working. And many of you have already been able to establish the account here. So again, not an issue at all so far. So it's strongly recommended that you complete all the reading material, any videos on big data management, storage, data lakes, AWS services such as what is S3, what is Glue, what is Athena. So you'll know that before you get into the assignment. Special instructions, if you're doing it in multiple steps, make sure that, you're executing it one after the other. If you have to kind of, if you're running out of time, you have to come back, clean everything, and then come back cleanly and run through from the top, right? But yeah, don't not leave it and just go away because it starts charging. Anything that you build in the lab, the clock starts right there and it starts charging you. And in this case, it's not charging your credit card, but it's going to take away the free $100 credit that you have. So I don't want anyone to run out of that credit. It's going to be very difficult for you to kind of establish another account if you run out of credit, okay? So please, this is a very important aspect that you have to always remember. You have to keep track of what you're using and that after you're done, clean it up. So when you've completed all the steps, complete the online quiz, you can refer to your document that you have, like assignment document. And when you completed the online quiz, submit the Word document into your assignment folder. And as I said, remember, you can always reach me and Yelena for any help that may be needed. Okay, so as I mentioned, clean up all AWS services used for assignment 2. ensure that AWS lab is being shut down. By the way, what to clean up, how to clean up is also part of the assignment step. It is the last step. So that last step you do not want to ignore, but to clean it up, okay? The AWS lab is available for continuous 4 hours. If you are getting close to 4 hours, log out before 4 hours and restart your lab and come back in, okay? And then assignment 2 is not complete until the quiz is attempted, which I just mentioned. Capture your screenshots and record your responses accurately in the assignment document as instructed, okay? And within the assignment document, you will see a rubric which is applicable to each of the sections of the assignment document. Okay, so I hope I was able to cover everything, but open for any questions that you may have for assignment 2.
I have just one thing. If you are getting close to I already did the assignment.
Okay,
if you
good.
get close to the end with the time, you can hit start again and it will reset it to 4 hours again without having to log off.
Yeah. Oh, okay. So yeah, when you are, see, the only problem there is okay, Sheldon, that you do not see it, but sometimes some of the services, if they are already on, it starts giving you errors if you're close to 4 hours. So that's what has happened to me. And that's why I said, like, you can cleanly exit out, come back to AWS Academy and just, end the lab and start the lab.
The other question I had was with question 19, which basically it just is kind of stated in a weird way, which loan applicants has the longest record credit history. The one thing that I noticed is, like, if you go down, it shows you like the max months that you actually have. And then if you scroll down the list, there's 65 of them. So it was hard to figure out, like, whether it was asking for how many applicants or like how long the application. That was just one of the weird ones.
Oh, okay. And I think that was for how many of them, right? Because 64 was one of the answers there.
It actually was the 96 on the quiz.
Oh, 96. Okay, right.
But yeah, it's question 19. It was just kind of weird. It worked like strangely. So I didn't know if you wanted to look at that or anything.
Okay. No, thank you for your feedback. Appreciate it.
Yep, that's all I got.
Okay, very good. Well, folks, you already have someone who's gone through the assignment and gone through it very well, as I know. So yeah, so as I said, it's not difficult and something that can get your feet wet and you'll get to know AWS much better, because based on this, you're going to kind of take this on and take this further into using some of the other AWS services. But any other questions on assignment 2? If not, any questions on module 2, module 1, or about the course in general? Is everybody feeling good?
No issues here.
Okay, excellent. All right, so I'll take silence as no further questions. So, thank you all guys for, being here. I hope, this was something that is going to be important and something that is going to be useful for you and for your journey in this course and learning as part of this course. Okay, so thank you all and good night, everyone, and good luck with your assignment.
Professor Inyasha, I have a question.
Sure, please go ahead.
Yeah, it's about you remember I asked you last time about the recommendation letter. How can we get it?
Say it again. How can you?
How can we have have a recommendation letter from you, and also?
Oh yes, I need to get back to you on that, Avner.
Okay, yes.
I'll write back to you soon. Yes.
Okay. Also about, I don't know if the other students still here. Can we endorse each other on LinkedIn? Our LinkedIn profile.
Yeah,
It can be
absolutely.
also
Yes,
helpful.
please feel free to do that. Yes.
Okay.
Yep.
Thank you. So
Sure.
if everyone can just drop a LinkedIn.
Yeah,
profile,
you can find me on LinkedIn. Yes.
Okay. I'm already connected with you in LinkedIn. I don't know if you know that.
Yeah. Okay.
Okay.
Sure.
Thank you, sir.
Sure, sure. Thank you. All right. If no further questions, thank you all. And if there are, I can be here. So do not hesitate to ask any questions or want to stay back, or I'm going to shut down the recording. So if there is something that you want to talk about, we can certainly talk, but I'm going to shut down the recording at this point. Okay.
Hi, Professor.